In today's class, okay. All right. So in today's class, we're looking at equilibrium of forces, and we're paying attention to moments of forces. We'll look at moments. We'll be looking at moment. What is moment? We'll look at moment, right? Then after moment, we could then consider. We'll look at the principle of moment, but I don't think those things are those. Probably just go straight. We'll look at moment of force. We'll look at moment of force. Then we'll look um, at couple, right? And we'll look at point forces. All right. Now, when we talk about that a body is in equilibrium, right? What does it entail when we hear that a body is in equilibrium? So, at any point in time that you hear about, okay, equilibrium, right? Can I even spell these things? So, when you talk about equilibrium, equilibrium of forces, what comes to your head first is the meaning of equilibrium. So, what does equilibrium entail? So, a body is in equilibrium when the net force acting on that body is zero, right? Which means the resultant force on that very object or on the body is zero. We say that that body is in equilibrium, that body is at rest, that body is not moving. Or even if it's moving, it is moving in a straight line, right? It's moving in a straight line. We say that the body is in equilibrium, right? Yeah. So in simple terms, we can say that a body is in equilibrium if the algebraic sum, right? Sorry, algebraic sum, algebraic, the algebraic sum of the forces acting on the object, the algebraic sum of the forces acting on the object is zero. I want to assume that everybody on the call has a very good knowledge of vectors, right? Resolution of vectors. So that's the concept we are going to be using right here. So when it comes to equilibrium of forces, we can have equilibrium of solids and equilibrium of what? Of liquids. So now under equilibrium of solids, I'll be focusing on equilibrium of solids for today, and then I'll pinch my nets on moment of forces and couples, right? Then later on, we'll look at the one that has to do with a point force, right? We'll have a point force and then that of a rigid body. So equilibrium of solids, under that we'll have the point body, have the point body, and then we'll have the rigid body. So for a rigid body, it's more like when you have a force acting on a particular object. That's what we talk about a point, like in terms of equilibrium is solid, a point body. But a rigid body has to do with when you have something like a length, right? You have a length of force, and you have different forces acting on it. I believe one of us or any among us must have seen things like this. So when you start seeing something like this, all of those things represent your rigid body. You have different forces acting within a particular body along a length, right? So this one has to do with your what? Your rigid body, and that is where we're going to pitch our net today, our tent either, right? Then you have your point body when you just have an object and you have series of forces acting on that very object. Do you understand it now? So that one we're going to use a particular rule to do that, which I'm going to show you within the week. Today is Monday. I'm hoping that by Wednesday we should meet, and then we should meet again on Friday so we can cover more, right? So you have that very body acting on that object. This is regarded as your what? Your point body. But today I'm focusing on what? On rigid body. Now, what do we have to know regarding your rigid body, right? So to actually consider our rigid body, we're going to pay attention to what? To moment of force. Now, if you can remember, for those of you that went to the secondary school, a very good secondary school like my secondary school, right? You must have done this experiment that we call the knife edge experiment. In that very experiment where you had something like a knife edge, then you have that meter rule People that went to a very good school like mine, we remember what I'm saying. You have a ruler like this. You have a meter rule. Sorry, my diagram is not diagramming today. Hey, an enemy has done this. Is it that my hand is shaking? Are you sure I'm not lacking blood? All right, we have this now. So now you have that kind of ruler, a meter rule on a knife edge. If you can remember, then we started placing things like mass to balance it. How many persons can remember that experiment? People that went to the kind of secondary school, I went to a very good secondary school, right? Good. You start placing things around it to balance it. You place things like the things usually round, different masses on it to balance it, so it doesn't keep moving, right? You still balancing those masses. Yeah, people that went to very good schools should be able to actually know what I'm talking about, right? So that is for these are the experiment or the things you learned. But then I think Titi is not talking, right? Titi doesn't know what I'm talking about. Lydian, Lydian, I know the kind of school you went to, right? So there's no need. So now, but people that went to that good schools like mine will see, and that is the experiment moment of force. You are hanging those things along that line so that it will be dangling. Let's say you have 50, I don't know, they are 50, that mass is 50 kg by the side, right? Then you have to start balancing like 20 and the rest of them. And the more you move it closer, the more you balance it and the rest of them. So that's where the concept of a moment of force is actually coming from, right? So what is moment? Moment is simply the product of force and perpendicular distance, right, of a line of force about a point, right? Is the product of the force and perpendicular distance. So a moment, in terms of the definition of moment, moment is defined. Moment is defined as the product is defined as the product of force and perpendicular distance of a line of action about a point. That is what we regard your moment as. So mathematically, we can represent moment to be equal to force times perpendicular distance. Remember that moment is different from your work done. Work done is force times distance, but this time around, the distance has to do with what? Perpendicular distance. Unlike your force that is just like your work done, that is just your force times distance. This one is now what? Force times perpendicular distance. So we have that moment is equal to your force multiplied by your perpendicular distance. As long as I'm concerned, I think physics has the highest topic in terms of other subjects. True of us. Yeah, I think it has the highest. We've not even done electricity. You still have electricity. You still have atomic physics. You still have wave, light wave, sound wave. This is quite big, actually. It's bigger than all my problems. Yeah. So first time perpendicular distance. So let's move and let's start solving questions as much as we can because we need to get our hands dirty. All right. Now, what is the principle of moment? Right. When you're taking moments, that's why they tell you clockwise equal to anti-clockwise. I believe some of us must have heard about that, isn't it? Some of us might have clockwise and anti-clockwise, right? So that's the principle of moments. That the sum of clockwise moments about a point is equal to the sum of the anti-clockwise moments about a particular point. Let's say that point is P, right? I'm glad that Lillian has said that one. Wow. So sum of clockwise moments about a point, C finish, Abi, is equal to sum of the anti-clockwise moments about a particular point as well. So now that is what we regard as the principle of moments. Principle of moments. All right. I know Lillian will soon swear for me. We have not done any topic in force field. Enya, what do you mean by force field? So this one you've been doing beyond Abia. What do you call it? Force line. So the principle of moments, that sum of clockwise moments. All those things are already in your dashboard. Though. Every video you need is already on your dashboard, actually. It's up to you. Clockwise moments about the point. Why I'm doing this particular topic is that it can be confusing. Moment P is actually equal to the sum of anti-clockwise moments about same points. All right, so all the grammar said, right? And another thing you need to know is that sum of forces of all upward force is equal to summation of the sum of all vertical forces. That is also the principle of moment, right? Upward force or upward force, summation of force in the horizontal direction is equal to summation of forces in the vertical direction. That's why we say that they are in equilibrium, right? So that summation makes it also the fact that both of them are equal is also a principle of moment, right? That all the vertical force is equal to all the horizontal forces. Please take note of that. There are questions I'm going to be solving that should be related to that very concept as long as moment of force is concerned. So we have right here that for forces up equal to the forces down. All right, that said, let's look at the key things we need. We also need our special angles. We have to know your special angles, very important. So there's a table I gave us before now regarding your special angles. Just know that that table is very, very expedient, right? Your sine 30, your sine 90, and the rest of them. But then to also give us a trick in case you enter the exam hall, right, of key things you need to always remember. Remember your special angles. We'll be needing our special angles to be able to tackle such problems, right? So a trick I can give you so you can remember, especially for some of us that like cramming. Well, if this one will help you, that's entirely fine. So remember you have sine, you have cos, and you have tan. So the key ones you need to always remember at every point in time, you should know 30, you should know 60, you should know at some point 45, and you should know at some point, you should also know your 90 degrees, right? We know that sine 90 is 0. Sine 30 is 0.5, isn't it? So that's 1 over 2. Here is root 3 over 2. Then know that tan theta, in case you can't remember, tan theta is what? Sine theta all over cos theta. Should in case you forget that of tan. Are we together now? So cos 60, cos 30 should give me root 3 over 2. Here should give me, I think, yeah, 1 over 2. Are we there now? Then check for tan 90, tan 45 and fill them up, right? So what I'm saying is that for your tan, you can always use sine theta over cos theta to get that of tan. So when you know the sine and cos, you can fill them up, right? There. So take notes in case you forget. Just do sine over cos. But remember that tan 90 is going to give you infinity. Are we together, guys? Tan 90 will give you infinity. Are you still following me? Give me a thumbs up, guys, if you are still with me. All right. So for sine 45 is root 2 over 2. right? Then cos 45, thank you, Paul. Cos 45 as well is also root 2 over 2. So when you divide sine theta by cos theta, you get that of tan, right? So it's something quite direct, you know. So, but tan 90 is going to give you infinity. Just take note of that, right? So if you can remember these ones, you can fill up the tan just by dividing them, and you are good to go. So sine 90 is 1. Then for me, I can't forget cos 90 because when I want to insult people, I will tell that person that the person is cos 90, you know. So what does it mean? That the person is what? Hey, the person is 0, right? That's what it means. I want to draw 0, but then the other guy is trying to show up, which is always a signal. So just divide your sine theta by cos theta, and you act accordingly to get the values, okay? Right there. So fill it up, right, to get the tan theta. So that said, let's look at the principles I want you to know, all right? Key things to know, key things to know to solve moment problems. Now, in order to solve your moment problems, these are key things I want you to understand, because at this point, I want to make things easier. Though I like people understanding the concept or background of things, but at this point, I think you guys can freestyle so you can cover up. Now, the first one is where you hear uniform meter rule. When they say uniform meter rule, one thing I want to come to your head is that if they didn't give you the length and they just say uniform meter rule, just know that the length of that meter rule is 100 centimeter. Just know that the length is what? 100 centimeter. So the first thing is when you hear a uniform meter rule. If they say uniform meter rule and they didn't say anything about the length, you are free to assume that the length of the meter rule is 100 centimeter. But if the length is given, don't leave the length they gave you to start assuming. At that point, you are on your own, right? So, but if they didn't say anything about the length and they just said 100 centimeter, you are free to say that it is what? It is 100 centimeter long. All right. So the next thing I want to talk about is that you should always take moments about the pivots, right? Or the what do you call it? Fulcrum, right? Example, if you've done simple machine, you have load, you have your effort, and you have your is it, how do you guys pronounce it again? It's still in the class.
Fulcrum.
Fulcrum. Fulcrum. Okay. You can't the answer like it's not sounding like fulcrum, like okra soup. All right, so we have fulcrum, right? So now, which is you remember when you did your simple machine, it's usually at the center. If you have your scissors, the fulcrum. Interesting. It's always at the center, right? You now have the load, the effort. You have the effort right here. For example, if you are dealing with scissors, you have effort. You have the fulcrum at the center, and then the load enters for your scissors and the rest of them. So it's more like the intersection. And if you play a lot, you can remember that there's something we normally do as well. We can put something, then there's something here. This person will sit down here. This person will sit down here. So if your weight is much bigger than mine, you should take me up. If mine is bigger, I should bring you up. But then if you bring two agidimbas and place here and place here, you will see that nothing will happen. So they will be in equilibrium because their weights are equal, right? When I mean agidimba, I mean people that have body well. Mm. So you understand. So now that in under it is your according to Rachel is your fulcrum. So now always take moments, always take moments about your fulcrum. Now, the pronunciation of this thing is quite sweet, though. And I don't think anybody should fail question on this because If you remember the way I called the fulcrum, you shouldn't make any mistake in the exam hall. You should just be hearing my voice as you're solving the problem. So let's take moments about the pivot. You can call it pivot or pivot, I don't know, or you can also call it your fulcrum. All right. So that said, the next thing I want you to know is that the mass, sometimes they tell you the mass of a meter, that the center of gravity, that the mass of a meter rule is acting at the center of gravity or is at the center of gravity. When you hear center of gravity, just know that it is acting at the middle. Do you understand now? So, though in engineering, there's something we call centroid. You start finding the centroid of an object. That one is a different ball game under what we call engineering mechanics. Quite interesting, but can be complex. So, but you have no business with that, right? So just know that when they say it's acting at the center or the mass of the object is at the center of gravity, it simply means that the mass is at the center of the meter rule or the center of the rod. So now the mass, sometimes they tell you that the mass of a meter rule slash rod is at the center of gravity. It simply means it is at the center of the rod or meter rule. Please take note of these golden rules. These are the golden rules. Is that okay? Center of the rod of the rule slash rod. All right. So I think for us to actually remember this, I think it's better I call it the golden rules, right? So that we can always remember. We'll use simple terms people tend to remember. So golden rules. All right. I know in the scripture we'll have golden rule as well, right? But if I ask us the particular passage now, touch will dismiss. Because I know some of you read your Bible 2 times a year. All right. So now the next one, yeah, but there's something called the golden rule in the scriptures now, isn't it? Good. So who can tell us? Church Abasa. Church has dismissed. Ebi Banio. All right. So your assignment, go and check it out. Do to others what you want them to do to you. God bless you. Where is the passage from? Emmanuel has said it already. So always look Matthew 7:12. Power. Always look out for all you people know is to be praying to God for you to pass your jam. Read Bible problem. It's just to be disturbing him. You want to pass your so always look out for the distance, right? Always look out for the distance, the perpendicular distance actually. Always look out for the perpendicular distance. Always look out for perpendicular distance. Perpendicular distance between, sorry, let me write abbreviation, between the loads, or in bracket, the forces at the pivots. The pivot or the pivot or the fulcrum. All right, so that said, these are the key things I want you to always remember. And having said this, let's get our hands dirty. Paul, you've sent the question I asked you to send, right? Have you done that? All right, good. So I will check your DM after we've solved these ones. So now let's solve examples. Now, the first question said in the diagram below, AB represents a uniform rod of length 1.5 meter. So in the diagram below, we have to be very fast. So let's look at example 1. So I will solve like 4 examples and then you start giving me your answers when I import some of those questions. The other ones I have as well, and the ones that Paul gave us as well. So in the diagram below, please pay attention now. The diagram below, AB represents, sorry, I know I should have written all of these things before now, but then the Son of Man, that will be quite a lot for me. So AB represents a uniform rod, but I think it's better this way so that you guys will follow as well, isn't it? Rod of length 1.50 meter, 1.50 meter, which is in equilibrium. So check the keyword. You've seen that that uniform rod has appeared, right? But like I said, if the length is given to you, don't assume it is 100. Are you there now? Don't assume it is 100. Unless the length, nothing was said about the length. So you assume that the uniform rod, since they said uniform, that the length is going to be 100 centimeter. So which is in equilibrium. So they said that guy is in equilibrium. So that word equilibrium is very important. So that those rules we've highlighted about equilibrium forces is going to come to play at a pivot P, right? So he said that if AP is equal to 4 centimeter, right? They said we should calculate the mass of the rod. Calculate the mass of the rod. For the questions you sent, they are similar to this, right? Isn't it?
Sir, they are more of the one that have tension.
That's what?
Those inclined plane ones, not this straight
Okay,
line.
inclined. Oh, okay,
Yes, sir.
okay. That makes sense. I love that. So after solving that of straight line, we move to the one that has angles. You are doing well. I will ensure that I give you one sachet of water, okay? Cold one, because the weather is very hot. Then I'll buy this. There's this something. This thing we normally buy as kids back in the days. This sachet Nutri-C, they sold 30 naira back in the days. You know that you buy it and then you put it inside cup and then pour water inside it. I know most of you will not know actually. It's only people that we are, I'm not talking about Indomie generation. Eh, I'm talking about people back in the days. So, Paul, I'll make provision for that for you because you're doing well. All right, so we'll have this. They give us the diagram, and then this is point P, and the diagram says we have A to P to be 40 centimeters. So this one, they give us the diagram. There are some that they will not give you the diagram. You're expected to draw the diagram yourself, right? So now we have that this is our AB. Okay, let me put it downwards. So they give us diagram. Here is A, and here is B, right? And the next thing they gave us right here is that here is 70, right? You have a force acting right here. Let's have here to be our A. Let me put it this way. Then let's have here, because the force is downwards. Here is our B. Then there's a force acting downwards this way. And that force happens to be 17 Newton. Now, they said we should do what? We should find the mass of the rod. So what are we expected to do right here? Now, remember what I said, that the mass will always act at the center, right? It will always act at the center. That's one key thing I want you to always remember. It acts as the center. So now let's carry this and replicate it down here. And replicate it down here, right? I feel I'm enjoying this afternoon class because I rested very well today from the stress of the last week. All right, so we have this right here. Good. Now, the first thing we're going to look at, if they said that the length of the meter is 1.50 meter, right? But if you check, the length that was indicated here is in centimeter, which means there is something that we need to do, people of God, right? This is 40. So there is something that must be done. And what is that must be done? Please, where is Dauda? She has not been joining classes. Anybody that knows her should they check on her that I'm asking about her. Okay, maybe I'll give her a call later today. I will know what is holding Dauda. All right, so we'll have that very length from here to here. That said, they gave us 1.50 meter, which we need to convert to centimeter. Remember, men and brethren, that 1 meter is equal to 100 centimeter. That means that 1.50 meter, the screen is blank. Is it for everybody? Okay, Richard, try joining back again. I think your network is after you. You can just check any electric pole close to you. Just climb a little bit so that the network will be clear. All right. So 1.50 meter will now be equal to 150. Yeah, is it clear now? Richard, equal to 150 centimeter. Is it still blank? Okay, good. You change your location. That's a good one. All right. Don't worry. When I become president, all of these things will end. If you don't even need data to log in. Just turn on your data, bam, with whether you have data on your phone or not, it will just be connected. Provided you are using it to learn something educational. Just vote me. All right. So 1.50 is equal to 150 centimeter, which means that the length of the meter rule is 150 centimeter. And remember that they said that we're looking for the mass of the rod. And remember what I said, that that mass will always act at the center, which means that we can resketch this very diagram. We can go ahead to resketch this diagram. And when we resketch, it means that the center, that you still have the fulcrum here, isn't it? You still have that fulcrum at a distance of 50 centimeter, 40 centimeter rather. We still have the fulcrum acting right here. And you still have that distance of 40 centimeter. We still have the perpendicular distance. When I mean perpendicular, I don't know if I explain what I mean by perpendicular. Like when you have a line like this, then there's another line this way, like forming angle 90 degrees. It means that the two lines are perpendicular. Or you have them this way, and there's another one acting this way. If they form 90 degrees, if the two lines form 90 degrees, it means that they are perpendicular. So that perpendicular distance, the lines must be perpendicular for you to get your moment. If they are not perpendicular, you cannot do that, right? What that entails is that you check now, this line, this force is perpendicular to this line. So I just have to multiply the distance because I'm taking the moment. I will take moment about the fulcrum, right? Or your pivot or pivot, and how you call it. So when you take moment about that pivot, which simply means that you are calculating the distance between the force multiply the distance away from the fulcrum. That's what it means by taking moment about the fulcrum. Do you understand? So the distance you are going to move from the force to that fulcrum is what we get as your perpendicular distance. And the fulcrum, the force should be perpendicular to the length or wherever place is acting on, right? So right here we have that this is 70 Newton. Now the length of the meter rule is 150 centimeter. So men and brethren, remember that here is your A and here is your B. This simply means that the total length, that the force, if here is 40, right, it should be divided. We should have the what do you call it? The force, the weight actually acting downwards here, right, which I can actually draw closer and bring it right here. So let's assume that here is your zero mark, here is 40. It means that the distance from here to here, please pay attention, men and brethren. This is very critical at this point. And if you miss it, don't call my name, right? Distance from here to here will now be 75 centimeter because the weight of the object will always act downwards, right? This is your W. Remember that W is equal to mg. So that way to be acting at the center. Now, but remember that this my diagram is a bit short, which means that this length should be extended a bit. It should be extended a bit. So let me see if I can extend it so that it will make sense actually. Yeah, I think it's more reasonable now. Good. Yeah, it's much more reasonable. So we have that here is your B. Remember, the entire length of the meter rule is 150. So it also means that here is also 75, isn't it? Distance from here to here is also 75, right? But the entire length of the object of the meter rule is 150 centimeter. Now they asked us to find what? To find the weight of the object. And remember that the mass of the object rather. And remember that the options they gave us, the options are in kg, right? But the weight of the object will be acting at the center. Now, what do we want to do, men and brethren? We want to get the moment of force. We want to do the moment. And the moment simply means is at every point in time, the golden rule said we should do what? We should take the moment about the fulcrum or the pivot. In anything you are doing, always take the moment about what? The pivot, or you can also call it the fulcrum, right? So it must always be the pivot and it must always be or the fulcrum, anyone. So I'm going to take moments about that point. Now, I might need to turn on my video so that you will have a concept of what this moment is all about, right? Let me quickly do that. Yeah. Richard, thank you for giving me that love emoji, because I find myself drawing it. But thank you. Why is it not pressing then? Okay. Yeah, confirm you can hear me. Good. Look at what I'm saying. Now, great. Now, if you are taking moments now, let's assume that we're going to assume key things. And what are we assuming? What are we assuming is that we have something like this. Now, there's a force like this. Something is at the center. Something's at the center, right here. And you want to take moment about a particular point. That moment is simply, I'll give you a shortcut as well, but then I want to get a concept behind it. Now, the concept behind it is that guy, can you see me please? That guy, assume that this is your fulcrum, right? Now, taking moment means that if you have a force acting here, you see what you guys are turning me into. Let's say that there's a force acting here, like the weight is. Let's say that, let me see if I will get another biro now. But then there's a shortcut to all of these things, but then just to give you a context of what I'm talking about. Now you have something at the center. Your fulcrum is at the center. This place I'm holding it. Now this is the weight of the object acting downwards. That line of force is going to extend. Not that it's not this way. That thing I'm drawing this way is just that the line of force continues. But actually the force is coming from down and then moving downwards. So imagine you are holding down here and then you have a weight pushing this object. This here is rotating now. This is what is happening. It's going this way. And clockwise means from right this way is your clockwise. So you can see that if I'm holding that center, that force is pushing this guy down this way and it's going clockwise. I'm not drawing anything. I'm not drawing. Look at me. You can't see my nose is at the center of gravity. If you can't see anything, I believe you can see my nose at the center of gravity. So now you can imagine that this thing is right here, is here, and then you are pushing it downwards, right? The force is going down. So it's going to rotate clockwise this way. It's going to rotate clockwise this way. Now, imagine you are holding it this way, and the force is now on the left-hand side. You see what will happen? If it's on the left-hand side of the fulcrum, what will happen? The force will push it towards. What's the direction now? What's the direction now?
Anti-clockwise.
Anti-clockwise. God bless you. It's going anti-clockwise. Now, that will bring us to something. And what does it bring me to? It brings us to the fact that at every point in time on the fulcrum, right, you're going to have a force on the left-hand side and a force on the right-hand side. Because if those forces are not on the left, on the right, the fulcrum will not be able to be balanced. So at every point in time, you're going to have forces on the left-hand side of the fulcrum and on the right-hand side of the fulcrum, right? And that's why we say that the anti-clockwise will be equal to the clockwise moment. So how I learned this was this thing I showed you, that when you are holding it somewhere and the force is pulling it down this way, you see the way it's rotating now, it's going what? Clockwise. Now, but if the force is acting the other way around, it's going this way, anti-clockwise. Love emoji if you get what I'm saying. Drop your love emoji if you understand what I just said now. Good. Titi has dropped one. I said love emoji. I didn't say give me thumbs up. Justice, what is your problem? Do you have issues with me? Eh? All right. That's entirely fine. You can't see anything. Hey, is your network? Oh. All right. So that's explained. Now, here is the shortcut at every point in time. Sorry, I don't want you guys to see my nose. All the best, guys. Bye. Good. So now I've explained what I want to explain. So let me proceed. Now, all right. So let's continue. At every point in time, you have that forces on the left. I don't want to use that clockwise. Forces on left of fulcrum. But even if you want to use that same distance, you've seen how it works. The side that will turn, if the fulcrum is at the center holding it, something is going to rotate, will be equal to forces on the right at every point in time. So your responsibility is now to look out for the perpendicular distance. That is the only responsibility you have. Looking out for the perpendicular distance. Now, let's continue with the first. The first guy, which is 70 Newton, is at the left-hand side of the fulcrum. Now I'm going to check what's the distance between the force and the fulcrum. Perpendicular distance. It is what? It is 40. So recall that your moment, is equal to the force multiplied by perpendicular distance. Rachel, can you see what I'm writing now? So sorry about your internet, right? Don't worry. I'm trying to come out for campaign next year. Seems to be a whole lot better. All right. So now, if you check for the 40 Newton, the force is perpendicular to this distance, right? To this very length. And the distance between them is what? Is 40 centimeter. So now, we have for the left-hand side, it is not constant. Okay. What you can do, can you keep the volume constant so that the pressure will vary? And then you can see your screen very well. Yeah, just try it. It's going to happen. So let's left-hand side now. So have your left-hand side. So the force is equal to what? 70 Newton. Perpendicular distance from fulcrum. From fulcrum or fulcrum. Yeah, I've forgotten what you guys pronounce this thing as well. Richard, how did you pronounce it again? Richard, can you hear me? Justice is again?
Fulcrum.
Fulcrum. Fulcrum. Oh, fulcrum. All right, let's continue. So now, for the left-hand side, it will now be what? The moment is going to be what? 70 times the perpendicular distance is equal to what? 40 centimeters. Is that not so? Times by 40, you give us the value. I can hear, but I can't see. You receive your sight in Jesus' name. Now, you should type on the chat, I am who? Master, I am who? I can see master. Master, before I was blind, but now I can see. All right. So left-hand side is 70 by 40. Then let's look at the right-hand side. Now I want us to think. Think, please. What do you think will be the distance, perpendicular distance between this weight and the fulcrum? What's the distance? Since from here to here is 75. What is now the distance between the weight of the object from the fulcrum? Which is this distance from here? From here to this place. Anybody attempting? What will be distance now from here to here?
It's 35.
I didn't hear you.
35.
I cannot hear you.
I said 35.
35. Any other person supporting 35? Yeah, Titi is supporting 35. Paul, 35. Richard, 35. Lillian, do you support 35? Good. So everybody will support 35, which means you guys are very good. So which means that here will be what? 75 minus 40. And that is what? 30. But that will be the left-hand side, isn't it? So on the right-hand side, on the right-hand side of the fulcrum, please. Okay, make sure your hands are up. What is the challenge, young lady?
How do you get that 75?
Okay, so this is how I got the 75, right? So remember, they gave us the length of the meter rule to be 150 centimeter, right? So they said that the length of the meter rule is 150. And then they asked us to calculate the mass of the rod. And I said that the mass is always acting at the center of gravity. And when I mean center of gravity, it means at the center of the object. Are you seeing it now? It's always at the center of that very length, right? And if the length is 150, then the weight of the object is acting at the center, which means 150 divided by 2, right? And that's why I have 75 centimeter. Is that okay now? All right, beautiful. So on the left-hand side of the fulcrum, we have the weight, which is mg, isn't it? That we have that mg, that's m times g is 10, then multiply by the length, which is 35. So note by that the perpendicular distance, this is the only example I'm going to be detailed like this. Other ones will just do left equal right. Perpendicular distance is equal to 35 centimeter. All right, so that said, you would see that nobody has given me the value for the left-hand side. Please multiply and give me the value. And on the right-hand side, someone should also multiply. Okay, that one should give me 350 m. So now we have the left-hand side, forces on the left-hand side of the fulcrum, which is actually your clockwise and anti-clockwise. But I want to use left-hand side and right-hand side. So, Titi, thank you. So Titi gave us the value, Titi Lola, of 2,800. And here is equal to 350 m. Remember that the m is the mass. So we're going to divide both sides by 350. Divide this side as well by 350. And when we do, we have that m is equal to what? M is equal to Titi. I will call you because you're the only person giving me the values. Other ones are just there, observing and looking. So what will it be? 280 divided by 35. What do you have right there? You can use 5. 5 can go into 35 to give us 7. Into 280 to give us, or 7 can go. 7 can go into 8 to give me 4. That's 40. 7 can go into 35 to give me 5. Isn't it? Is it 8?
8.
8. Do we have 8 in the option? Are we sure we are correct, young people? Someone said the answer is 8. Let me quickly cross-check again. If you have 70 here, oh, okay, that force is 700 actually. That Newton force is 700. Sorry, guys. From the past Christian is 700. So this is 700. Sorry. So which means it will affect that value, isn't it? Will you increase or will you reduce? It should reduce, isn't it? Um, 700 by 40. I think it's going to increase. 28123. It's going to increase to 80. But I also have. I didn't hear you. It's going to increase. It's going to increase. I don't know whether this what they wrote here is it 70 or 700. Okay, let's maintain 70. Let's maintain 70. So they gave us G to be what? I think G, I didn't draw very well. So this is 10 meter per second. See the error. They said this is 4 cm, please. I have seen it. The length is 4 cm. Why is a human being like me is writing 40? So here is 4 centimeter. I know that's what the question was okay. Right. So here is 4 centimeter.
I've seen this
So which means
question. Oh.
you've seen it, right?
I've seen the question, but the parameters given was 40 cm and then 7 Newton, not 70 Newton.
Okay,
So after
okay.
solving, you bumped up 0.8 kilogram. The
Okay,
answer
you've seen the
is
question before. Somebody say power. Okay, here it should be what? AP is what? 4, right? Or 40? Is that what you said?
40.
40.
Then
Okay, 40.
yeah, the other one is 7
Oh,
Newton.
7 Newton, not 70. Okay.
Yes, that's the problem. Yes.
Yeah. You know, when I'm bringing out those questions, I'm not even looking properly. When you feel you know something, then you copy the wrong parameters, you will sleep there. Isn't it, guys? You will sleep there. All right, so this is 75. So this is 7. So sorry about this error. So my bad. The past question, I didn't bring out the question properly. You know, I was talking while writing at the same time. Okay. Solving with 70 and 4, I got 0.8. Then solving with 7 and 40, what do you have? You should get the same answer as well.
Yes,
You
it's
should
still the same
actually.
answer. 0.8.
The same answer. Okay.
Yes.
So sorry about my own wrong listing. You know, I was talking while writing that question down. So this is 7 Newton actually. Here is 7. Here is 7. But the main thing, you understand the process. The value is not a problem, isn't it? Isn't it? The value is not a problem. Yeah, once you get the concepts, value is not a problem. And I think that's why I made that mistake of the values. So this is 280, right? This is the forces, right? And you're multiplying, this is Newton centimeter, right? Because you're working with moment of force, right? So after doing that, we're now dividing 280, we're divided by 350. Every other person in the house, hope you are following, guys. So here we'll cancel out. So Richard, is it that you crammed the answer?
No, I solved it today though. I bumped into it today.
Oh, somebody say power, please. All right, so that's 0.8 kilogram. So the next example, are we ready now? All right. So the next example is okay, let's take a look at this. Any question? Hope everybody's following. Okay, make sure your hands is still up. Do you still have question or the question you asked before? Okay, good.
Sorry.
It's fine. It simply means you are lifting up your holy hands. Your hands are holy, isn't it? Hosanna is in class today. Wow. Glory to God. So we have that a uniform. Welcome, brother. I'm glad to have you. So a uniform meter rule. AB. I just want to solve a few more. Then I pick those questions that Paul sent to us very fast. So we have a uniform meter rule is balanced on a knife edge, which is 56 centimeter from B. If a mass of 10 kg is hung at B, which is 10 centimeter from A, calculate the mass of the meter rule. Since we've done something about mass before, is it ideal? Okay. This one is one we're going to draw this one ourselves, right? That's the difference. They didn't give us a diagram. We have to draw the diagram ourselves. So uniform meter rule AB is balanced on the knife edge. Is balanced on the knife edge, which is 56 centimeter from B. if a mass of 10 kg, sorry, 10 gram is hung, sorry, at P, which is 10 centimeter. Remember when you did, for those that did mathematics and you did bearing, when you hear the word from, it means something very key. The word from is very key, right? As long as mathematics is concerned. So they say we should calculate the mass of the meter rule. All right, so which approach do we use here now? So we have that option A, we have 70 gram. Option B, we have 50 gram. Option C, we have 100 gram. And option D, we have 40 gram. All right, so that said, pay attention to this. I'm going to use this diagram. So they said the uniform meter rule, and they didn't tell us anything about the length. So because of the uniform, they said, we are assuming that the length is 100 centimeter, right? Is balanced on a knife edge. You know your experiment, knife edge, which is 56 centimeter from B. 56 from B. Take note of this statement right here. From B. Take note of that statement. They said it is 56 from B. Then if a mass of 10 kg is hung at P,
saying 56, but you wrote 55.
I keep saying 56.
Yes, but you wrote
On,
55. So which one are we
sorry,
going with?
sorry, 55. Sorry. I need to do curing. You know what is curing? Hosanna. I think it's only Hosanna and Justice that will know what is curing, and then Chinonso. I think I need to do curing. Exactly, food, my bro. Who cooked? Justice. So now, if a mass of 10 gram is hung at P, which is 10 centimeter from A, right? Now calculate the mass of the meter rule. So it's 55 please. So now let's draw solution. So the sisters in the house, they don't know what is curing. Wow. You guys should know some of these terms. So when somebody say they need curing, you know they are talking about food. All right, so let me draw a line. So let's draw the line, and we are taking the length to be 100. I wish I need to solve a lot of questions today, especially those ones that the angles are inclined that Paul sent to us. So this is the length, 100 centimeter. So what's the next statement they gave us? You are drawing this one yourself. AB is balanced on a knife edge, right? So which is 55 centimeter from B. So we'll have A to B. Are you there now? We'll have A. This is B. But they said that the knife edge is 56. My God, is 55 centimeter from B, right? So the knife edge, distance between the knife edge from B, that the distance from here, let's say the knife edge is here, right? Let's say the knife edge is here. That the distance between the knife edge and B from B is 55. So please, if I say 56, just know that I'm talking about 55. Oh, please, have mercy on me. So here is what? 55. Now, but remember that the weight of the object is going to act at the center, right? And that center should be somewhere here. That will be what? W equal to mg. Now, what does that tell us? If the weight is acting at the center, 50, right? 50 centimeter, because that length is 100. So here is W equal to mg. Remember that the entire length of the object from here through, the entire length of the object from here to here, right? So if we take the distance that the total length is 100 centimeter. But at the midpoint, it's going to give us 50 right there. But the distance from here through to this place is 50 centimeter. So someone will agree with me that if that's the case, right, someone in the house is going to accept that here, the distance from here will be 5 centimeter. Right, distance of the weight from the fulcrum is going to be 5 centimeter. So it didn't end there actually. It didn't just end there. So they said something about if a mass of 10 gram is hung at P, which is 10 centimeter from P, 10 cm from P. That means if you are coming from A, it is 10 cm, and that value there, that weight there that was hung from there, which is from here, is what is 10 gram. Right? Then remember that that distance between the two of them, which is ranging from here through to this place, is going to give us 10 centimeter. And that will let you know, which means that the distance from here between the two of them, right, is going to be what? 40 centimeter. The distance, perpendicular distance of that weight P, right? This is point P to the fulcrum is going to be 40 centimeter. If you agree with me, can you just give me a thumbs up, please? Sorry, love emoji, please. All right, Anita, good. Hosanna, well done. Titi, well done. Justice, yeah. Yeah, good. Everybody good. Everybody good. Everybody good. Good. Anyone confused? All right, we're all good, right? Good. Nikki Good Silver, you don't attend our meetings. You just join classes when you want to join. What is the problem?
I thought it's 45.
Is it
Hello,
45?
sir. I
Yeah,
thought it's
no, it's not.
45.
Okay,
Because
It will be 45.
No, it's 40.
it's 45.
40.
okay. Those that are saying 45, why do you say 45? Because the center is okay. Okay, I think you guys are making sense. Are
45
they making sense?
55.
Okay, look at it. Let's observe it properly, please, so I don't make mistakes. Okay. Now look at it. From here, we're looking at the center here is 50, right? And we're looking at the distance from here to here is 10. Then here is this is 45 right here. Oh, yeah, makes sense, guys. Remember that from here to here, yeah, that's a very good one. If we are to draw so that others will understand, people that make that correction, lessons. Now, if they are to understand something, it is important to note that distance from here to here, the entire length remaining here is 45 centimeter. Do we agree? From here to here is 45. If from here to here is 50 centimeter, 55. If from here to here is 55, it means that from here down is 45. Do you agree? Everybody, do you agree? Yeah, we are all in sync. Good. Now we are now looking for, right? If then remember that this side now, but from here, let me shift this 45 a bit. Please, the only thing that will fail you in this is your inability to look at the distances correctly. But now take note of this, men and brethren, that from here to here is 10 centimeter. So if here is 10 centimeter now, what is down? Even people that said 45, you guys are wrong as well. But then you took my attention to something. Good, 35. People that said 45, but it is okay because you drew my attention to something, right? So that means that distance from here to here will not be 45. Do we agree, guys? Do we agree, guys? So what I can do for us, let me extend the length a bit so that it won't be confusing for us. Nikki Good Silva, you said battery, but I know that okay, I don't want to talk. If it's delivery that you want to do now, you will not say that battery is a problem. You want to deliver to customer, you have to find a way to deliver the product. Oh, Louisiana Jambe, it's no battery. So here is 45 centimeter. All right, so this is 45 centimeter. Then remember that this is your point P, right? Here is your point P. Then we want to get that here to here. Sorry, a lot of things are going on here, but just understand it that here is 10 centimeter. So if here is 10 centimeter, it means that from here to here is now 35 centimeter. People of God, do we understand? Everybody, do we understand? Hope we're not leaving anywhere. Lillian, are you there? Do you understand it? Yeah, no, so well done. Titi, well done. Anointed. Lillian, are you on the call? All right. All right, good. So let's continue. We leave no man behind, okay? So now let's go. Remember what I told you? That at every point in time, there will always be a force at the left and right of the fulcrum, fulcrum. So now, so you have on the left, so that when people will listen to this recording, they will not say, this kind of teacher will not sabi pronounce things. So from the left, I will stop calling the name. Huh? So remember what I told you, that from the left and right of this thing here, good, let me save myself stress. There will always be a force at the left and at the right of this guy here, right? Good. So now, the force on the left hand side of this guy is what? Is 10. We're going to change it to Newton because this is mass. So mass times acceleration due to gravity, right? And this guy is at the right hand side of this thing here, right? So which means that our moment is going to be what? The left hand side of that guy, which is what you call this thing I just wrote now, is equal to the right hand side of this stuff I just wrote now, right? So the first one is for the left hand side. For the left hand side, we have the mass, which is what? 10 grams. So multiply by 10, that will give us 100 Newton. So the perpendicular distance, I will write it as P point D. Perpendicular distance is equal to what? So distance of the 100 gram from that guy here is 35 centimeter. So this is 35 centimeter, right? Then on the right hand side as well, we have that we have mg, isn't it? Right? That is in brackets 10m because your acceleration due to gravity is there. So p distance, right? The distance of the center or the weight of the object or the weight of the rod from this guy is 5 centimeter. So we have that very place to be 5 centimeter. So here is 5 centimeter. So therefore we have that 100 on the left hand side multiplied by 35 is equal to 10m multiplied by your 5. So this will give us 3,500. 3,500 is equal to 50m. So we're going to divide both sides by 50. Divide both sides by 50. And when we do, you would see that what will happen right here is that 50 will cancel 50, 0 will cancel 0, 5 here is 1, 5 into 35 is 7. So we're going to end up with 70 gram, right? Which is option A or thereabouts. So the mass of the object, so mass of the meter rule is equal to 70 gram. All right, guys. Any question on this? Are you following, please? Everybody following, right? We are all making progress, I believe. Right, yeah.
So I didn't get how they got the final answer. That's 70.
Oh, so I divided both sides. I didn't use calculator. I had to just use my this thing, normal, we call it box stop method. So 50 will cancel 50, 0 cancel 0. 5 into 35 is 7, then you have 0. So that's how I got 70. You can just punch your calculator. But I'm using the box stop method, how we divide things without getting to use calculator. Is that okay, Richard? All right. Well done. Everybody, we understand what we did, right? Everybody, we are all on the same page, isn't it? Okay, Hosanna, your hands are up. Hosanna, what's the challenge? Go ahead, Hosanna.
Sir, please, I'll be back.
Eh?
I said I'll be back. I want to attend to something.
Okay, you're to your customer, I know. Okay, no problem. Collect change, okay? All the best. Right, let's go to number 3 now. The class is recorded actually. The third one, are we ready? All right. I think we've done this. So let's look at the one that has to do with ratio. Then I'll import some of those questions and we'll proceed. All right. So this is example number 3. I hope everybody's following so far and that everything is making real sense to you. There is so much. This is just for the rigid body. I'm still have to do for the points, right? For the point body. But I think I'm going to give us that point as an example or assignment to go look it up. And then we'll meet on Wednesday to finish it up. So now masses. Sorry, Rachel. You can mute, okay? Are you driving or something? Okay, now must conduct a while I so now we have that masses M1 and M2 at the 20 centimeter and 35. I don't know. We had only Igbo people and Yoruba joining the boot camp. So why is it that I didn't have anybody from the north? I think for the next boot camp, I will for the next boot camp, I will ensure that we have people from the north. We didn't have anybody at all from the north. So because I want to do Wazobia, I want to learn how to speak Yoruba and then how to speak Hausa as well, So I'm surprised only those 2 people that joined. People from the west and people from the east. So we need the north, okay? So we can balance up things. So now they said that masses M1 and M2 at the 20 centimeter and 35 centimeter marks respectively, very fast guys, respectively, of a uniform meter rule, freely suspended at its center of gravity. If the meter rule balances horizontally, determine the ratio M2 to M1. All right. Does it make sense now? Determine the ratio M2 to M1. So how do we get this ratio of M2 to M1? So in order to get that ratio of M2 to M1, let's actually sketch and see what it looks like. So we'll have masses M1 and M2. Look at the marks they kept it. Sorry, this is 65 actually, not 35. Like I said, I need to do curing. So now, we're taking note of those 2 masses. They gave us what? M1 and M2. And we'll have it at 20 centimeter and at 65 marks respectively of a uniform meter rule and is suspended at its center of gravity. If the meter rule balances horizontally, determines the ratio. Okay, so now let's do that, guys. Now, solution. Now, the first thing we need to do is to sketch our line right here. We draw a line. I want to draw now. Let's sketch. And we're assuming that it's going to be 100, isn't it? The length is going to be 100 because they said a uniform meter rule. So let's sketch right here. Sorry. That was bad of me. All right, so let's have that to be 100. And then the meter rule, they give us masses M1 and M2. Right, so let's call here, let's use A and B. Let's say we have A here, right? And let's say we have B here, right? Now, let's have here to be our 0 mark. Then here is our 100 centimeter mark, right? So they said something that the 2 marks, right, at 20 centimeter and 65 respectively are suspended, right, at its center of gravity. So it's at the center of gravity, right? If the meter rule balances horizontally. So what are we going to do? The pivots or the pivots, and then your fulcrum, right, is at the center, isn't it? Is at the center. That's what it means. Is at the center of gravity, right? Which is what 50 centimeter. This is what they said. Is suspended, is freely suspended at its center of gravity. That means that the fulcrum is at the center of gravity, which means distance from here to that place is 50 centimeter, right? So that means that it means that the distance from here, guys, to this very place, the whole of here, is going to be what? It's going to be 50 centimeter. But then we'll have a mass hung at 26 centimeter. So we'll have this point. Let's say this is our first one. This is my M1, and M1, the distance between M1 is hung at the 65 mark, right? So at the 10th mark, I mean to say. So that means from here to this place, it's hung at what? 25 centimeter mark. And then they said that M2 is actually hung at 65 centimeter mark on the meter rule. So if here is 50, it's safe to call here 65. It's very safe to do that, right? Yeah. Men and brethren, are we following? The women of Jerusalem and the brothers in Judea, I hope we all are following. All right. So here is M2. And remember that they said that your M2 is at a distance of 65 meter, right? So it means that the distance from here through the whole of here to this very point, to this point here, is 65. So here is 65 centimeter. But remember that our goal to take the moment, right, about the fulcrum is that we are always taking the moment about the fulcrum, right? So now taking moment about the fulcrum, we're going to do left-hand side. So taking moment about fulcrum. You also know that it's always what? The left-hand side, right? Always equal to the right-hand side. So forces on the left equal to the one on the right. Now, people of God, you're going to see that the distance between our M1 and the fulcrum is 30, isn't it? So the distance between them is 30. Isn't it, guys? So here, the distance between M1 and our fulcrum is going to be what? 30. And the distance between our M2 and the fulcrum, who can tell me the distance between our M2 and the fulcrum?
15.
15. Beautiful, brotherly, because from here to here is 50. So that place is going to be what? 15. Well done, brother. Do we understand why it is 15? Do everybody understand why it is 15? Lillian, do you understand why it is 15? Hope you do understand why it is 15. Right there. So that means on the left-hand side, we have M1, right? So on the left-hand side, we'll have the force right there is what? M1 times the distance is what? 30. Then on the right-hand side, we have M2 times by 15. So based on your moment, we have the left-hand side is equal to right-hand side. So 30. When I say left-hand side, I mean the forces on the left-hand side of the fulcrum is equal to the forces on the right-hand side of the fulcrum, not just left-hand side equal right-hand side. You must observe the fulcrum, right? Because I'm just using that shortcut for you not to be looking at anti-clockwise and clockwise. Because why I learned it was that moving left, moving right, like when you hold that point. So, but to prevent you from acting that drama in the exam hall of holding the pen at the center and be rotating it as if something is wrong with you, you know, it's better to just use that you have left and then right. All right, there. So now let's proceed. We have 30 times M1 is equal to 15 times M2. So that is that 30 M1 is equal to 15 M2. So we're going to divide both sides because they say we should find the ratio of what? The ratio of what? M2 to M1. So that means M1 will be on top. while M2 will be beneath. So I'm going to divide both sides by 30 here by 30 M1, then all over, because they want M2, ratio of M2 to M1, right? So which means that if I do so, 30 will cancel out. 15 here is 1, here is 2. So it simply means that M2 over M1 right there is going to be what? 1:2. And if you check the option, I know they will also give us 2:1 in the option. If you are not careful, they will give you, they want to confuse you, and then you will go and make that mistake. So we'll have that M2, pay attention, over M1 is equal to 2/1. So that M2, sorry, 1/2 rather, is 1/2. So that the ratio of M1 to M2, M2 to M1 is going to give us what? 1:2. And I promise you, in the past paper, the options, one of the options was 2:1. So you have to be very careful, the one that is on top, based on what they are asking you. Are we together?
I even stopped and saw 2:1. Hey.
So you have to look at what they said. They said determine the ratio of M2 to M1, which means M2 over M1. So when you divide both sides, you have M2 is 15, right? Because they said M1 is at 20 and M2 is at 65. So it has to do what? M2 over M1. Does it make sense, guys? Does it make sense, everybody? All right. Beautiful. Beautiful. Now, the final one I'm going to solve that has to do with these straight lines. Then we'll look at the times where the forces are not perpendicular. The force is not perpendicular to the distance, or the distance is not perpendicular to the force. Because for you to get your moment, it's going to be force times perpendicular distance. And if they're not perpendicular, you have to resolve the forces or the distance per se for it to be perpendicular. So we have that a uniform example. What now?
4.
Example 4. Beautiful. So example 4, others are not following, don't mind them. You're the only one following. So we'll have that a uniform. Yes, now because you guys don't know the example I stopped, whether it's example 1 or example 2, you guys are just there because if you're following me, you know the example I stopped. So a uniform meter rule. So we've set 50K for anybody that will score. What was that? You said above what? Above 300, right? Was that what we promised that day, Paul?
Above 300. 50K.
Above 300, right?
Above 350. More than 50K.
You say above what?
Above 350, you said something special.
Okay, something special.
I'm not agreeing with Paul. Paul is saying the wrong thing.
So Titi, I said 300 and above is 50K, right?
No, you said 300 and above is 30,000, and person that gets 350 and above is 50,000.
Okay, that was what I agreed on. Okay, so 300. Okay, 300 above is 30K, right? Then 350 for 50K. Okay, yeah, that was the agreement, guys. So we'll have a deal, guys. So let's see how it goes, and let's see people that will be pushed. You know, beyond the money is that you're going to enjoy the admission as well. Maybe me and you go do the course now. So, and you also be proud of it. If you're walking on the road, you'll be like, anybody you see, you have to find a way to push the discussion so that the person will ask you your exam score. You know, that kind of thing, you know. Yeah. So, but if you don't do well, any discussion towards jam, you are running, like you want to dodge the discussion. So that's one good thing about having a very good score. So uniform meter rule, weighing 0.5 Newton, is to be pivoted, right, on a knife edge. They are using a knife edge, right? Knife edge, and the knife edge is 30 centimeter apart. Okay, these are 30 centimeter mark, right? All right. So where will a force of 2 Newton be placed from the pivot to balance the meter rule. So are you seeing that very question now, right? So where will it be placed to balance the meter rule? Option A says 35 centimeter mark. B says 25 centimeter mark. C says 20 centimeter mark. And D says 5 centimeter mark. All right, so a meter rule is weighing what? What's the weight? 0.5 Newton. They've given us the weight of the meter rule. And remember that the meter rule will be acting at the center of gravity. The weight will be acting at the center of gravity, right? And then it's to be pivoted, Abby, on a knife edge at 30 centimeter mark, right? So this is 30 centimeter mark. Remember that since it's a uniform meter rule, that the length is 100, and the length is 100, where will a force of 200 Newton be placed? Right, 2 Newton be placed, I mean to say. Right, so let's first of all start by drawing the uniform meter rule. So our solution, let's quickly draw the meter rule. So let's have our meter rule drawn from here. All right. So now, and you have the weights, meter rule weighing this is to be okay on the 30 mark. So here is 0, and here is 100. And it is being placed, the fulcrum is at the 30 meter mark. So let's have it here. And sorry, this is too far. So 30 should be here. So it's at the 30 centimeter mark. So the distance here is at 30 centimeter. All right. So now, they said where with the force, okay, then we'll have the center. The object has 50 Newton, so you should act at the center of the object. So of the meter rule, so here is at the center, and at that center, we should have the weight 50 Newton. And then the distance apart from here through to that point, as the case might be, should be 50 centimeter. Right? And if it's 50 centimeter, it simply means that we should have the distance from here to here to be 20 centimeter. Isn't it, guys? So if that place is 20 centimeter, the next question, the question now said we should do what? Where will a force of 2 Newton be placed from the pivot to balance the meter rule? So where are we going to place a force of 2 Newton to balance the pivot? Now look at this. Remember what I told you? On the right hand side, there should be force on the right hand and the left. There's no force on the left hand side, but there's a force on the right hand side of that pivot, which means that that force is likely going to be at the left hand side. So, but the challenge now will be the distance. We are looking at the distance. So let that force be P, and let that force be at the left hand side. English. Be at the left. Let it be at the left hand side of the pivot. You know, Titi, what's the challenge? Is it that you don't understand, or is it my challenge with English language? I'm an engineering student, so you don't expect me to blow big grammar. You know, they taught me equations now. All right. So now on the left hand side, we're going to have that force on the left hand side here. So let's call that force P. Now, they say we should find where we are going to place it, isn't it? So now, where do we place it? We are looking for that force P, and that force is going to be on the left-hand side. So we are looking for the place where we are going to place it, right? So let the force be P. We don't know where it's going to be. Let the force be P. Right? But should be on the left-hand side. Are you seeing it now? NB, but should be at the left hand side of the knife edge. All right. So that said, we can now go ahead and do our left hand side equal right hand side. Do we understand what I'm trying to do, guys? Do you understand what I'm trying to achieve? Is it only Richard that understood what I'm trying to do? Rich, Meso and others, what's happening? If you are confused, give me a thumbs down. Okay. Okay. Grace, Susan, I never knew you on the call. All right. So now, when you check, you have a uniform meter rule weighing 0.5 Newton is to be okay on a knife edge at 30 centimeter mark, right? So look at what I'm saying. We are looking for where we're going to place that force P. Where are we going to place the force P so that it balances up? That's what we're looking for. We don't actually know where to place that point P, right? We have a force which is 2 Newton, but we don't know where to place that 2 Newton so that there will be a balance. But remember that for there to be a balance, that P cannot come at the right hand side of the fulcrum. So it can only come at the left hand side of the fulcrum. That's the only place that guy can come, like the P. But we don't know the distance. That's the challenge. We don't know the distance of that very guy from the fulcrum. But we know that it should be at the left hand side because the anti-clockwise should be equal to clockwise. And because of that, this guy is already at the right hand side of the fulcrum. P should be on the left hand side. Do you get the point? But we don't know the distance. I don't know if you've gotten the revelation now. Titi? Do you get the gist now? Lillian, do you get the gist now? Anointing, do you get the gist now? Anointing, I know you gave me a thumbs down before. Does it make sense now? All right, so let's proceed. I'm glad it makes sense now. So we're looking for that P, we don't know it. But then we know that on the left-hand side, we don't know where that distance will be, right? So we have 2 times, let's call that distance D. We don't know the distance between them, right? The distance where that thing is going to be, but we know it should be at the left-hand side at all costs, right? But we don't know the distance from the knife edge, right? But let me speak in King James. But we know not. The distance from the knife edge. You know that translation now. If you're not careful, if they ask you to read Bible in church and what you have is King James, you're going to disgrace yourself. It will not look as if you don't know how to read. All right, so let's proceed. So now, this is the force, which is 2. This is the distance, we don't know where it is. Then the right-hand side. On the right-hand side, they've given us the values. So the right-hand side is 50 Newton, and the distance is 20, right, for the right-hand side. So we're going to have 50 times by 20. So 50 times 20. So for them to balance up, we know that 2 times that distance, we don't know the distance of that P from the knife edge. Should be equal to, for them to balance up, should be equal to what? 50 by 20. Now, that said, this will give me that 2D is equal to 0 times 0, 0. 5 times 2, 10. Hope I'm correct, isn't it? Sorry. That should be more than this. Should be like 10,000, I mean. Or is it 1,000? I don't know math again. Can I proceed, guys? Yeah, it's 1,000. So we divide both sides by 2 so we can get the D. Susan, do you understand it now? Susan Grace, do you get the point now? All right, beautiful. So we have that D is equal to, so let's divide both sides by 2. Cancel here by 2, cancel here by 2, cancel here by 2, cancel here. You're going to have 500, right? Is it 500? Oh, sorry, I'm using the wrong values. This is the force is 0.5. I don't know why what I have with increasing values. I don't know my
I
problem.
said it. I knew it. Oh God.
You knew it. You knew
She
it.
said
You didn't
it,
say
but
it.
you aren't looking
Yeah,
at it.
down.
You knew it, but you didn't say it. How
She
come you
said
knew
it.
it and you didn't
She
say
said
it?
it.
Asked
She
in the
said it.
comment. I said 0.5 and 50. I was
Oh,
confused.
oh, sorry, I didn't see that in the comment, please. I
She said
apologize.
it
Nikki
before.
Gotsiva, Nikki Gotsiva and the Meso, I apologize, please. I did never see that in the chat, okay? And other persons didn't highlight that. I apologize, please. I will not do that again. Sorry. I need to do curing. I keep saying it. So here is 0.5. So we'll have 0.5. So sorry about that. 0.5 times 20. So the mind is saying something else and the hand is writing something else. Sometimes it can happen. But don't try that when you are working in the bank. The next time you're going to find yourself in the prison. So this is 10. So we divide both sides by 2, right? So that will be that D is equal to 5. Is that okay, everybody now? Has that been corrected? People that said they were confused before now, Nikki Good Silver and
So what does that letter do with that 30?
what will letter do with it?
The 30 cm mark.
30. We used it to get the distance between the both of them because from here, the distance of this mark from the 0. The pivot, it gave us where the fulcrum is. So the fulcrum is at the 30 mark. So if from here to here is 30. Now we're looking for the distance between the width and the fulcrum, right? So that 30 centimeter actually helped us to get where the knife edge is placed. So the knife edge is at the 30 mark, which means 0 to here is 30, right? The distance from here to the knife edge is 30. Then I'm now looking for the distance between our center mark and that knife edge because the 0.5 is going to be at the center, which is at 50 centimeter. So now 50 minus 30 will now give us a distance between perpendicular distance between the width and the knife edge. Does that make sense now? Isn't it?
Oh, I'm getting the wrong impression. I saw this exact
Sorry.
question.
So are you confused?
Yes, sir.
Okay. Dear Lord, open our eyes to understand. All right. So look at it. Look at it
Amen.
here
But
now. Your eyes are made open, right? Go ahead.
okay, I saw this particular question, but they saw this in a very
Okay.
wrong way, like in a different pattern. I got 25
now.
after 7 minutes in a past question.
Okay. Let's go again. Let's go again now. So what was the pattern they used? Hello, Rachel. Can we brainstorm together? What was the pattern they used? Can you hear me?
Yes, sir. They said 30 minus x is equal to 5. That's 5 from wait.
30 minus x equal to 5.
They actually used x as the unknown, like the unknown force that we used to balance the.
Okay, go ahead. Then they did 30 minus x. Is that what you said?
Yes, it's equal to 0.5.
Okay. 30 minus x equals 0.5.
Yes. Sorry.
30 minus x. Wait, I'm coming. Let me get your point. 30 minus x equals 0.5. I get that your 30 minus x, but you know the challenge is that we can't actually dictate where the actual location of the the force. I think I get your point as well. I get your point, and I get what you're trying to say. But the challenge here is how do you, okay, 30 minus x. Guys, hope you guys are following to get the bone of contention. 30 by x. I think I get your point actually, but then sorry about the noise in the background. 30 minus x. Okay. So if you're doing 30 minus x, you're trying to say that the distance, okay. Now for your 30 minus x simply means you're looking for here from here, okay, from here to here, because it must certainly fall within this range, right? So they did 30 minus x is equal to what? Rachel, are you there?
Okay, 30 minus x is equals to 5. So they now got x
Yeah.
is equal to 30 minus 5.
So where are they getting
Then they
the
got
5 from?
25. I'm even very confused. But it's same question. Oh.
No, I disagree with them. I can. Okay. Okay. So I have what? I have the first distance is 5, isn't it? Okay, look at it there. Look at it. Look at what they are trying to do there, right? So to finish up our question first, look at what I'm going to do. Are you paying attention now? Are you with me? Now, what I got here, we have a distance. Pay attention now. The d now is equal to 5, right? But then we still have to find the location. Are we together now? Follow me. Can you hear me? Everybody. So you don't cram what they just did here. Look at it. We are still on point. You have that 5 right here, right? You have your 5. The d is equal to 5, which means you are getting the distance. But they want us to get the mark where the force will be. The mark on the meter rule. Are we together? Nobody's responding again. Rachel in particular, are you following me? Good. So Rachel, look at the points now. You have the position where that force is going to be. But remember, they want you to get the mark, like the particular mark on the meter rule. But first of all, you still have to balance up your equation. What we did now is just exactly what we are going to do. So the force distance now, right? The distance of the force from here, let's go to that my diagram now. So now it means that the distance of the force from the fulcrum is 5 centimeters. That's the distance of the force from the fulcrum. Now, to get the mark on the meter rule, because the equation says we should get the mark on the meter rule, where will the force be placed to balance the what? The meter rule. So at what mark am I going to place it? Now, if the distance between the force and my fulcrum is 5, remember that this fulcrum is at the 30 centimeter mark. Now, imagine the distance from here to here being 5, the first distance being 5. What will be the mark at this point? You know the meter rule is calibrated, but for you, you are cramming that 25. The process is still the same. Our process is still the same, and we're not yet done with that our process. So the first thing I'm going to do is to at least get the first distance, which is 5 centimeters. Right? This is very correct. The first step. But now that 25 you are talking about, for you to get 25, you must first of all arrive at this d equal to 5. You know, you said something. Say 30 minus s equal to 5. Where is the 5 coming from? Nick Gotsiva and the rest of them. Are you following me now? So where is the 5 coming from? So the 5 is coming from the fact that we have to get the first distance first, which is what we did here. And after that, if the distance between the knife and the force, it means that the force P, this is where P is going to be now. Now, what is now the mark on the meter rule? I don't know if it's making sense to you now. What is now the mark on the meter rule? Because remember that when they gave us this 20 that we got here, this 20 was the distance between our fulcrum and the what do you call it? The weight of the object, not the mark on the meter rule. So this is 0.5. I left this 50 here. So that said, in this my diagram, if I'm to replicate this diagram now, let me clean this place and clean here, then bring back that diagram again. So Richard, don't be confused. You have to get the distance between the force and the fulcrum. So now this means that D is equal to 5 in brackets distance the between force P and the fulcrum. So let's close up here. Good. That done. The next thing I'm going to do, let me sketch that our plan again so you understand better. You don't just say, okay, if you have another question, doesn't mean that every question you do 30 minus you put the 5 there. Do you get my point now? Is it any question you do minus 5? Your 5 is not flying from anywhere. It's coming from somewhere, which I just calculated now. Now, we don't know where that distance is initially. That's why we calculated. Now, we know where the force is. So the force P is at a distance of, this is now where my P is. P is now at a distance of 5 centimeter, I mean to say. This is where P is. P is now 5 centimeter away from the pivot. Right? So what will now be the mark on the meter rule? Can someone tell me now? What will now be the mark? At which mark will this thing be now? Since the distance from here to here, I will talk tired today. And it's Richard that caused it, because if she allowed me to get to the final answer, it would have been easier for for her to understand, right? If you allowed me, it would have been easier for you to understand. So now look at this. Remember that there's a mark here, there's a mark here, there's a mark here, there's a mark here, there's a mark on these things. These are marks on the meter rule. So now on that meter rule, this is your 100 centimeter mark. Now the center of gravity is at the 50 centimeter mark. So the mark here is at 50 centimeter. Here is 50 centimeter. Your pivot or your fulcrum or the knife edge is at 30 centimeter mark. But force P is at a distance of 5 centimeter from your fulcrum. Now, at what mark would this thing be? If here is 30, 30 minus 5 is not 25. So here now is going to be what? The mark here for that force is at the 25 centimeter mark. If you understood what I said, aside Richard, now give me a love emoji for other persons in the class. If you understood what we just did now. Good, good, good. Richard, are you still confused? Are you still confused? Okay, beautiful. So you have to get that distance first. Where that, and the only way we can do that is to do left hand side and right hand side. So now this is distance from the fulcrum. Hence, the mark on the meter rule will be equal to what? 30 minus the distance, which is equal to what? 25 centimeter. Why is it 25 centimeter? Because the force is 5 centimeter away from the fulcrum or the fulcrum. Is that okay? Everybody. Any question? Any question, guys? All right. A love emoji food. Okay. Okay, Richard. Okay,
Sir.
you said? Go ahead.
So the final answer is 25.
Yes, 25 mark. Yes.
Are
But
you
you don't.
confusing myself? I thought it's 5 Newton.
No, it cannot be. Look at what I'm saying. You know, I was calculating something when you paused me. I was trying to get the D. Yeah, that was you said 30 minus 5, and I'm asking you, where is the 5 coming from? You are looking at your step, but you don't understand why the 5 is there. I was at this very spot when you stopped me. I was trying to get the distance between the force and the fulcrum. I've not arrived at my final answer. You get the point. So I stopped at the distance between the force and the fulcrum, right? Which is what? P. But then you have to get the mark on it. But for you are looking at the past question, you're saying 30 minus x equal to 5. So is the 5 coming from the moon? Is that okay? Can we proceed now? I have a class at 5. So Paul, you forwarded those things to me, right? All right. I'm coming. Let me quickly check something. I have a class now. Let me check whether he has joined. Now the next question, can you check those questions that Paul you sent to the group chat or you sent personally to me? Is Paul on the call? Okay, not on the call. So look at what will happen if we are willing, we can still continue by 10 p.m. tonight. So I can handle those ones on a client, or else we leave it for Wednesday. Or else we leave it for Wednesday. Okay, let's continue. The person have not joined yet. Let's continue. So let me pick those questions that Paul sends to me so we can navigate. If you are still with me, give me a thumbs up, please. Yeah, Paul, you have beautiful questions right here, actually. Very beautiful questions. I love them. I love them. All right, beautiful. So let me forward. But it looks like the pod that brought the questions is no longer on the call. Hmm. 24 powerful questions. Boy, no grill. Okay. I want to get two of them that has angle, like two. Okay, let's use this one. Let's use this two. Let's use this three. Okay, let's use this four and see how far we can go. Let's use this five. All right, so done. All right, great. Let's proceed, guys. Can you see my screen? Confirm you can see my screen. You're leaving Niger first thing tomorrow morning. Okay, now. We in a landlord now. We in a landlord, though. We go nowhere, guys. Okay, so look at this one. The angle is inclined. It has an inclined angle. So I'm going to solve just one of them, right? Then maybe we'll see how it goes much later. All right. Sorry. My mic has been off. Nobody's saying anything. So sorry about this. So I said something that all we need to do now, sorry about this. I never knew I was muted. You have a force this way, acting this way, but then what you're looking for is a perpendicular distance. So for the perpendicular distance, we have to resolve it to come like this. So it's going to be perpendicular. It should be a straight line, not slanted, because we're working with what? The force times perpendicular distance. So now I'm asking us, if I resolve this force, I've written the answer, you guys have seen it already. It's going to be what? T sine 30. Do we agree? When we resolve that force from slanting this way, we'll take it to the vertical. Do we agree? If you agree, give me a thumbs up. All right, we agree, right? Good. And Mesoma and the rest of them, do you agree? Do we agree? All right. So we have T sine 30. So what are you going to do now? You take the moment, right? The mass of the block is 0.5 and it's suspended at 40 centimeter mark of a light meter rod, AB, that is pivoted at E, the 90 centimeter mark, and is kept at equilibrium by a string attached at point D, the 60 centimeter mark, as shown in the diagram. So you're looking for the tension. What are you going to do? If here is C, remember there's a force here. So that force is acting downwards this way, which is 0.5. What's the distance between, from here to here, what's the distance? Who will tell us? What will be the distance from here to the fulcrum?
60.
From here to here will be what? No, why will it be 60? Here is 40. Here is 90. This is 90 mark. Here is 4. You're looking for distance from here to here. This is the 40 mark. This is the 90 mark. 50. Beautiful.
50.
So yeah, here is 50. So how about the distance between the tension and the fulcrum? What will it be? Here is 60 mark. Here is 30 mark. What will it be? Distance between the two. I mean from here to here now. I didn't hear you. Who is talking?
30.
30. Good. So now we can go ahead and find the answer now. So remember that they gave us the mass is 40. I have another session I'm rushing. So you have 0. Oh my God. So this is 0.5. Are we together? Multiply by 10 to convert it to mass, to Newton, times by 40 is equal to, that's the left-hand side. That one is at the left. But I think both of them are at the left-hand side. Both are on the left-hand side. And that's where we are going to apply that thing I taught you. That moment stuff. Apply that thing I taught you. So we're going to use clockwise and anti-clockwise at this point. So clockwise moment equal anti-clockwise moment. Right? So this is clockwise, CW. So imagine you are holding this thing down here, and the force is here. It's going to take it what? Clockwise. So you're going to have the clockwise is going to be what? T sine 30 multiplied by the distance is 30 is equal to anti-clockwise. Pin this place down. If you pin here down, see that force is going to push to the left-hand side, which is anti-clockwise. So that is going to be what? 0.5, which is kg, times 10 times the distance, which is 50. So now we're going to do T sine 30. Sine 30 is 0.5. This is 0.5 T times 30 is equal to 0.5 times 10 is 5. 5 times 50. So now we are going to multiply both sides, right? So when we multiply both sides, we should have, if you are following, give me a thumbs up. If you are following me, why I use that clockwise and anti-clockwise. If you know why I had to use clockwise and anti-clockwise, give me a thumbs up. This is 15T right here. Good, Justice, thank you. Any other person that knows why? If you don't know why, give me a thumbs down. If you are confused, give me a thumbs down. This is 250. Anointed, you are confused. Anybody that is confused? Nikki and Susan are confused. This is 15. This is 15. So that T is equal to, I'm running out of time and that's why I'm rushing. This is 16 point something, right? So T is equal to 16.67 Newton. Now look at what I said. Remember that when I explained these things to you, you saw that all the questions, when it has to do with, when the force is not inclined at an angle, are you paying attention? When the forces are not inclined at an angle, we use that left-hand side is equal to right-hand side. That all the forces, at least, they should have one force on the left-hand side of the of the knife edge, and you should have another one at the right hand side of the knife edge, right? But for this very question now, the tension is inclined, and you can see that all of them are on the left hand side. You don't have anyone on the right hand side. So which means that you cannot do left hand side equal right hand side for those ones that are inclined. So you have to use clockwise and anti-clockwise. And when I started the class, I explained something. I said that you have something this way. This is a line. This is more like you have a pen like this. Now, this is where you are holding that edge. This is the 90, that's the place the knife edge is. This is your knife edge. Now, the T sign, tension is pushing it this way. If the tension push up, it is going clockwise. Now, again, if you hold it down here and it's pushing it downwards like this, it is going anti-clockwise. So clockwise equal anti-clockwise because of what? Is inclined. But the normal ground, you should have forces at the left-hand side and the right-hand side of the knife edge. Do you understand it now? Do you understand now? Susan, do you understand it now? Anointed, do you understand? All right, so I'll see you guys later, please. I'm running out of time, so we'll continue next time. So check those questions that Paul sent. I'm going to forward it to the group. Try to get your hands dirty, okay? And I wish us the very best. Observe the situation when the angles are inclined, right? If they are inclined, you have to learn your clockwise and anti-clockwise, just like I showed you. All the best, guys. I'll see you in the next section. Thank you.
What's popping?
Why are you guys still here to leave the call?
You
I'm
guys
waiting for
asked what
you.
I used to do here.
You guys should come and be going a big.
You have to turn your videos on now. Turn your videos on.
Justice, your line is breaking.
I said turn your videos on.
You told your own, or you want another person to turn their own on.
No, if you turn, I'll turn.
I'm not doing it. You that is telling us on our own, or your own phone.
Yes. You have to lead by example, Justice.
Okay, don't have to turn your camera on. Bye bye. He's outside and he's outside. But I don't see your face, young man. Hey. So how you guys in, like, how is studies going so far? Because I don't know.
I
For
don't
me,
know. When they reach, I'll see
So you
Shaggy.
get
I'll see Shaggy.
okay.
yeah,
I'll
I
see
know.
Shaggy.
It's fine. These two shall pass. By the end of next month now, everybody will just be minding their own business, do what they feel like when they feel like. You will not even be having in mind, wake up early to read until you probably gain admission. So let's just what will I use?
The main thing is to pass the exam. So if you don't pass the exam, you will not feel okay.
I swear. Omo, I cannot imagine feeling the way I felt last year this year again. It's going to be horrible.
Oh, even to check your result,
Hmm.
I'll take like days before I check my result.
But there is no only you. I don't check my own email. I'll wait because the tension. If I just see a result is out, my mind will do fiam.
The pressure.
Let's see here
It's
that
not that it's not that
70%
you
of
don't know
people
what
fail.
you wrote. It's not that you don't know what you wrote, but then you don't know. You are very unsure.
When you hear 70% of people fail down,
I swear.
check your own way, problem.
Oh God.
Someone said if he checks his own early, that he's not sure that he is going to pass.
Whether you check early or you don't check early, your result is still your result.
It will not change.
Hey.
Alright, man. I mean, I know Gift is far ahead now. She's always answering questions.
It's not easy, oh, it's not easy. I'm trying to pour in everything, my energy, my time, my resources, everything into the exam because I don't want history to repeat itself. Last year was terrible for me. It was very awful. I fell into depression last year, safe. Because last year was not just jump. I also did a pre-degree program at Unisic. I got a good score. I did not fail until they transferred me to geological science. Jesus, the whole thing broke me.
Wait, which four subjects did you write last year?
It's still biology, chemistry, and physics. But it's not just jump. I was also working with pre-degree results. I did a pre-degree program there 6 months. So
Okay.
um, the whole thing was devastating. You should have seen me last year.
The thing
That's
really
why
affected you.
it did a lot to me. So that's why I'm putting in everything. And imagine people that you stay in the same room with them, you spend the same time, you eat together, you bathe together, you do everything together. Everybody have moved on and nobody's even checking up on you again. It's heartbreaking now.
That's how it is now. Okay, you used to go to boarding school, right?
It's not no, I didn't go to boarding. I went to boarding school, but I was a day student. But
Okay.
then yeah, I'm talking about the pre-degree program. Most of them got admission. But me, you have
They
seen
may
me.
even send you, they may even send you again.
Nobody remembers
What
me.
course?
Even people that remember me now, are people that I don't even pay attention to that time.
That's how it is. So.
Wait, this call is still recorded.
Jesus Christ. Anybody that,
Jesus.
anybody that comes better to watch you will be listening to us. So.
No, Mr. Luther will cut it.
Okay, now.
I don't know. I don't know if you cut it. Let me stop talking.
If you guys want to talk, you go to WhatsApp now. I beg.
Bye bye. Because
God. Oh.